Alright guys, welcome to our channel Code with Sunny, and in this video I will be talking about the problem. You can see largest plus sign, its index is 764 and it is the medium type problem, the LeetCode. Okay, so to be honest, I really like this problem, and the reason behind this is if you look over the constraints, I was trying to have the different type of solution. Like first I've used the brute force, then I've used the binary search, and then finally the ultimate best solution. So like I was aware that these type of solutions like brute force and the binary search is not going to pass, since the constraints like the n value is around 500, and this brute force will take a time of around O of n cube, so this is obvious that I think it is not going to pass. But if you look around the binary search approach, it took the time, like the time complexity is around O of n squared logarithmic of n, and space complexity is O of n squared. But still, you can see I've been delivered this verdict. Like all the test cases passed, but your code took long to respond. Yes, so I need to optimize again. So then finally I came up with the solution, like time complexity O of n square and space complexity O of n square. Now, to be honest, to come up with these type of solutions, like directly, this one is quite difficult. But if practicing enough, that is, if you have still solved these type of problems, where it is Google, Kickstart, yeah, I've already opened it for you guys. Okay, so you can see that this is the problem has been asked in like this year Google Kickstart round A 2021, and it is the second problem, I think. Yeah, it is the second problem. So like the problem is quite similar, and it is called the variation of this problem. Like in this problem also you need to find out total number of L-shaped figures, all consisting of I think yeah, I think the values are 1 also. Yeah, the cell containing the values of 1. I don't know, but you have to be like finding out the total number of L-shaped figures possible. Okay, in the that is possible in the grid. And if you are done with this question, I will strictly recommend you guys to do this problem. And again, if you are stuck upon that, go come out to the playlist section of my channel. You will find out the. Okay, so I will guide you from the very beginning. Come out to this playlist section. You will find out Google Kickstart Round A editorials, and here are the 4 problems, and this is the problem round, like the second problem, L-shaped plots round A 2021. You need to click over here, and there's the 17 minutes video, and it will explain you all the concepts. Okay, so coming back to discuss the original problem. Yeah, so what we have to do is, like, we have been given an integer n, and there is an n into n binary grid with all values initially 1 except for some indices given in the array mines. That is, we would be given a 2D vector also, and size of like mines, like named as mines. And like initially we would be having a n into n binary grid, like it can consist of 1 or 0, and initially it is all filled with 1, and we would be given some minus vector where it will be denoting two values xi and yi for every particular input, and where if we be given xi and yi, then the grid of consisting of this coordinate will be filled with 0, and what we have to return is the largest axis aligned plus sign of ones contained in this grid. You can see that this is the largest one that is being possible over here. Okay, and if there is none, return 0. An axis aligned plus sign of one's order of k has some center grid RC exactly equal to 1. You can see that this is the center, and with 4 arms of length k minus 1, that is the lengths are same, and k minus 1, you can see there are 4 arms, left, right, up and down, each having the length 1, you can see over here, going up, down, left, right, so on, and made of ones. Note that there could be zeros or ones beyond the arms of the plus sign. Only the relevant area of plus sign is checked for ones. You can see that this is the largest one. You cannot extend either of the arms to one more length, because you need to maintain the lengths of each of the arms to be having the same length. Because same length having k minus 1, where k is any integer. Okay, if you are not getting the problems right now, no need to worry about. I'm going to explain this with this examples. So let's head over to the explanation part, where I will be explaining what this problem is going to show off and what could be the best solution for this problem. So let's move further. Okay, so suppose that we would be given this grid consisting of like everything is going to be filled with let's say one. Like this is not zero. Imagine that there is one. Now we would be given a minus 2D vector where every input is going to consist of two numbers x comma y. If it is given x and if it is y, then the corresponding value in this grid becomes 0. So we would be given some like this type. So let me erase this 1 and put a word 0 over here. So here in this case mine's vector 2D vector is of size 1 and the inputs are for this coordinate, that's why here it is 0. Okay, so we need to find out the largest plus sign. So you can see that largest plus sign can be like of this one. So let me just draw this one. So you can see that this is the largest plus sign. Why this is the largest plus sign over here? You can see that here it is the center and all those lengths that are length of the arms that are to the left of it of this center and to the right of it of this center and similarly to the up and down are of same length. Let's call the length as k. You can see that one length and again here it is length of one and the length of one. That's why you can see that this is a plus sign, valid plus sign, all consisting of ones, and all the arms are having the same length exactly equal to 1. And if I will consider this as the plus sign, what is our answer? Our answer will be what is the length of the common arm to the all the surrounding this center? It is 1 plus the center value, that is 1, that is exactly equal to 2. You can also consider the answer as like this one. You can see that what is the length of the longest arm considering the plus center of this plus sign and including that plus coordinate. You can see that here it is of length 2 and here it is of length 2 and here it is of length 2 and here it is of length 2. This is the largest plus sign that you can get over here, and you cannot like extend this plus sign to some more extent. Let's try to have a different plus sign over here. Let's try to explore something more. Consider this as your center. If I will consider this as your center, let's try to understand. And suppose that I am going to extend this part, that is the right arm to the one more length, and right up arm to one more length, and left arm to one more length, and similarly the arm that is present over down to one more length. Okay, so this is the answer. Like here, the answer is 2 right now. Note that you need to ensure that left, up, down, and right arms consisting of ones should be of same length. Now you can see that here is also one. I can extend this to the one more length, that is the right arm. In that case also you need to ensure that all the up, down, and left arms should also be extended to uh, one more cell consisting of ones, but you can see that when you try to extend this down arm, here it is 0. You cannot do that. So it means that the extending the either of the arms to one more length is not possible. So our answer is 2 and this is the maximum answer that you are going to get. Okay, so doing these type of brute force is not optimal. So what you are going to do is let's try to understand how this plus sign is going to play an important role. Now consider all those arms, left arm, right arm, up arm and down arm having the 0 length. Now you can see that all these arms are having the 0 length. Okay, in that case our answer is 1, right? And consider that length of the up arm, down, left and right are exactly 1, like plus sign having this type, like this one. This is a valid plus sign, all consisting of ones. Okay, these all are consisting of, our answer in this case is 2. Okay, there might be some cells. Okay, so there is one more important thing. There might be some cell to the left of the left arm and similarly to the upside of this one, to similar to the downside and all those one. Okay, but you need to ensure that whatever the cells that you are going to consider with respect to the center of this plus sign should be consisting of all those ones. That is, suppose that here it is 0 over here. Okay, and you are saying that I'm going to consider this plus sign. Okay, note that I'm talking about the plus sign contained in the yellow. Okay, so I'm going to consider this plus sign as the valid plus sign. This is not going to be possible because here it is one of the zeros. If you look out the problem statement, It is saying that all the ones contained in this grid. Okay, so you need to focus over the only ones. And the thing is, I'm talking about the plus signs right now because this is going to be important. How this is going to be important? Let's try to understand this by fixing the center and extending the arms. Okay, so let me just erase this one. Okay, so let me take this color. Now consider the case like if you try to say that this is the cell and this is the center of this plus sign. Okay, and you need to find it out that what is the largest subarray consisting of ones and ending at this cell and coming from the right hand side. That is, I'm talking about the right arm. If you're not getting it right now, let me explain, let me speak out again. The thing is, you need to focus upon the right arm right now, and I'm talking about the largest subarray ending at the current cell, that is this cell, and coming from the right hand side, and all consisting of ones. Okay, so suppose that there is these type of cells that are present to the right of it. Okay, if these type of cells are present to the right of it, and this is the center of this plus sign, you need to ask to yourself that what is the largest subarray ending at this position and coming to the right hand side and all consisting of ones. You can see that this is the subarray. You're not going to consider this zero. Okay, and similarly, if you are being able to find out for all those arms, that is for the up one and for the left one and for the down one. Okay, what is the largest subarray that is coming from the upside and all consisting of ones and ending at this current cell, which I have considered as the center of this plus sign. You can see that here it is of length equal to 3. Yes, right. And similarly, what is the largest subarray that is coming from the left hand side and all consisting of ones and ending at this position? You can see that it is of length 3 here also. It can be of any length. Okay. And similarly, you are going to find out for the downside also. And let's call it as, let me write down R, and let's call it as U and L and D, where R is the length of the largest subarray that is coming from the right hand side of the current cell coordinate and ending at this particular cell. Okay, and similarly U is the largest subarray that is coming from the upside, that is the same column, okay, and ending at the current cell and all consisting of ones. It is going to be denoted by U, and similarly L and similarly D. Then our answer would be, like if I would consider this cell as the center of this plus sign, our answer would be what? Minimum of L, R, U and D, obviously, because I need to ensure that all those left arm, up arm and down arm and whatever it is are should be of same length. Okay, that's why I'm taking the minimum. Okay, now the thing is like we have already approached the answers. We need to find out the largest subarray consisting of ones ending at the current cell and all containing ones. And but how do we find out for all those left arm, right arm, up arm and D, like the down arm, for every cell at every position of this matrix? How it is going to be done? And like if you say that if I am fixing this cell, you need to know for this column also and for this row also, and from coming from the downward also for the same column and for the same row coming from the rightward also. You need to know the directions values for all those uh, for all those four directions. That is the largest subarray ending at this current position and all consisting of ones. Okay, so before approaching to this one, you need to understand for the linear array. Okay, now consider that you have a linear array, and this is the linear array, and let's say you have this and 0. Okay, and if you have been given this one, and you need to be like, you need to find out the what is the largest subarray that is all containing ones and ending at this current position, any position I, and coming from the leftwards. Okay, so if you need to find out for this position, let's say what is the largest subarray that is coming from the leftwards, ending at this position and all containing ones. You can see that it is of length equal to 2. That is this one. And similarly, if you try to find out for this position, it is of length equal to 3. But how do we find out efficiently in O of n time? Okay, so what you are going to do is like consider the solution first. Okay, now whenever you are going to encounter the 1, you need to do the prefix sum, and whenever you are encountering the 0, just leave it as it is. So okay, so that is I'm going to do the prefix sum, that is from the leftwards. So I'm encountering 1, so I'm going to do the prefix sum. 1 plus 0 is 1, and again I'm encountering the 1. I'm doing the prefix sum. 1 plus 1 is 2, and again I'm encountering the 1. I'm going to do the prefix sum. So 2 plus 1 is coming out to be 3, and I'm encountering 0. Just leave it as it is. So let's try to have this modified array. Like I'm going to erase this first, so it will be like 0, 1, 2, 3 and 0. Can you just elaborate that? Yes, I'm getting the valid answers. That is what we want. If you try to focus over the statements, if you just say that I am going to try to find out for this position, what is the largest subarray that is coming from the leftwards and ending at this current position, all containing ones, should be answer equal to 3. Yes, it is. You can say that this is the largest subarray. Okay, so we have already found out the approach. We need to do the prefix sum. That is, if you try to find out for this position, considering this as the plus sign, and if you need to find out the L value, that is the length of the largest subarray, all containing ones coming from the left hand side, you need to do the prefix sum for this particular row, like this, like in this way, and you are going to get the answers for every coordinates of this particular row. And similarly you are going to do in the right hand side also, and similarly you are going to do for the upside also for every column, and similarly you are going to do from the downside also. Okay, so if you are going to do from the downside, that is for every column you are going to do, in this case also you need to do the suffix sum for every column, right, like in this manner. And if you are going to do in this way, then for answering this cell, you are going to answer this in O of 1 time, and you need to do some prerequisite pre-calculations, and it would take of O of n square time to do that. Okay, so you are going to do for every row and for every column, what is the largest subarray coming from the respective sides and ending at the current cell. You are going to find out for every cell, and you are going to store it in a row like format for every row, and similarly you are going to do store for every column also. Okay, so if you're not going to understand this, I think you would be better understanding with the help of coding part. Let's try to understand this with the help of coding part. Okay, so let me just open up the code. Here you can see that the time complexity is O of n square, space complexity is also O of n square, and like what I've done is like I've written down the 5 vectors. So original vector MAT is going to store the matrix, and there is a left also, right also, up also, down also, being all initialized with 1. Okay, and we are going to fill the certain cell values with 0 when we try to traverse the minus vector. You can see that I have filled mat, left, right, up and down with 0 at the corresponding coordinates. Okay, now this left 2D vector is going, that is the left of ij is going to store longest consecutive plus ending at this ij coming from the left direction of the current cell. And similarly the right, up and down. Now I need to just fill up this all these 4 vectors. So I've iterated for this n times, like this is I, and it is I being iterated n times, and for every j I need to fill up this left ij and need to fill up this down ij. Okay, and similarly I'm going to fill up this right, and similarly I'm going to fill up this up, and I'm leaving this up to you to understand this, how this is going to work, because this is pretty much easy. You can do it with your own by writing the 2 or more lines of code if you're not going to understand this compact code. Okay, so you can do that. And what we are going to do for this answer, as like I've initialized answer as 0, and I'm going to consider every cell, like consider every cell as the center of this plus sign, and we are going to consider only and only when this mat of ij is consisting of 1. That's when we are going to consider this as the center of this plus sign, and we are going to find the answer for every cell being considered as the center of this plus sign. like we need to maximize the answer, and our answer should be max of answer and minimum of this value. If I'm going to consider this current cell as the center of this plus sign, note that you're going to have the left of ij, right of ij, and up of ij and down of ij. That is the, if you understand the meaning of left of ij, what is the length of longest subarray coming from the left of this current cell, that is same row, and coming from the leftwards and ending at this current coordinate of the cell and all containing ones, and similarly the right, up and down, and you need to maximize your answer and finally return the answer. Okay, so if you have any doubts, do let me know in the comment section of the video. I will be happy to help you, and I will be asking for you to like this video, share this video, and subscribe to our YouTube channel for latest updates. Thank you for watching this video.